10.6 is about finding the segment lengths inside a circle, okay? So we're not worried about finding the arcs and angles, which we know how to find from 10.5. We're actually going to find the length of segments. So we're going to highlight one segment in one color. We're going to highlight the other segment in a different color, okay? Now, I picked red and blue. Both of these segments represent what? What's their name with respect to a circle? Chords or chords? Chords, right, yeah. We're going to make the CH silent, so it's going to be a chord, okay? So, the red and blue lines here represent chords, and where do those two chords intersect? They intersect inside the circle, right? Remember last class we talked about chords, secants, and tangents intersecting on, in, or outside a circle? So here we have two chords that intersect inside a circle. Alright, so when two chords intersect inside, here's your formula you're going to have to remember. Okay? The first is part times part equals part times part. It'll make more sense here in a second once we talk about what this part means. Okay? When I say the word part, I'm talking about taking the segment and looking at the piece of the chord that represents one part and the other piece of the chord represents the other part. So here, X represents a part of a chord. The other part of that same chord is 3. So if I was going to find a segment length with two chords that intersect inside, I'm going to do part times part, meaning 4 times 6, and that's going to be equal to the other chord broken up into two parts, X times 3. So if I follow the chord going from one piece to the other, okay, part times part equals part times part. 4 times 6 is equal to X times 3. Everybody see where that comes from in the picture? Alright, so from now it's pretty easy algebra steps. 4 times 6 is 24. Sometimes I rewrite X times 3 as 3X. I like to put my number in front of my variable as a coefficient. And I'm going to divide both sides by 3 to solve for X. 24 divided by 3 is 8. 8. And that's my final answer for that one. Part times part equals part times part. Yes?
Is it always going to be just numbers, or
It could be, yeah, it could be segments, things like that, yep.
So is that saying that they're equal to each other?
It's not saying that they're equal to each other. It's saying that the two parts, in terms of their sides, they're proportional. When I'm taking a product of two things, I'm more talking about proportionality than I'm talking about congruency. Okay? Because 3 times 8 is 24, and 4 times 6 is 24, but the lengths of them are about the same. Length of the blue is 10, length of the red is 11. Okay? Alright, so let's look at our next example. Here I had two chords that intersect inside. Now I have two what? What are these called? They're not chords anymore because they go through the circle and they don't stop at the edge. They're called... How many times did that line touch the circle? Once here, twice there, right? So when a line touches a circle twice, what type of line is it? It's a secant. It's a secant. So here I have two secants. I have two secants. And those secants intersect where? Where did they touch?
outside?
Outside the circle. So I'm going to write outside here. So I have two secants that intersect outside the circle. My formula that I need to remember is a little bit different than part times part. And it's going to be outside times whole equals whole. Not like a hole in the wall, but like, yes, whole milk. Okay? Times outside times whole. Okay? Now, outside is specifically talking about the secant, the part of the secant that lies outside the circle. The whole represents the entire length of the secant. So when I look at the green line, which number or variable represents the part that's outside on the green line? 5. Everybody agree that 5 is talking about from the edge of the circle out to the intersection, that's 5. So outside would be 5. What's the length of the whole green segment? And this is where we got to be careful because this is one of our common mistakes. If I'm trying to add up two pieces of a line, I add them together, I don't multiply. So if one is x and one is 5, the entire segment is going to be x plus 5. X plus 5. I'm glad you guys said 5x because that's the common mistake that everyone always usually messes up on. Okay? X plus 5 is the length of the entire segment. So the inside is x, the outside is 5. When I add them together, that gives me the whole segment. That's going to be equal to the outside times the whole in the orange secant. What's the outside piece? 6. And be careful. What's the whole piece going to be? 9 plus 6. So some of you are going to, for right now, let's write out 9 plus 6 to remember that the whole is the whole segment. It's 9 plus 6. But a lot of you are going to be able to do that in your head or in your calculator pretty quickly. The whole segment is 9 plus 6, which is 15. So we're going to do 6 times 15, and that's going to be equal to 5 times x plus 5. Now, when I have parentheses like that with 5, what should I do? Yeah, I'm going to make sure I distribute the 5 into the x and into the 5. Common mistake is we distribute to the x, but we forgot to distribute to the 5 as well. So when I set up 6 times 15, that's going to be equal to 5x plus 25. Go ahead and take a moment here and see if you can solve that equation for x. 6 times 15 is 90. I'm going to subtract 25 from 90. So 5x is going to be equal to 65. And I divide 65 by 5, and what do I get for x? 13. X equals 13. Make sure you remember to box or circle your final answer so you understand where your answer is at. Good. So we down 2. We have one more to go. That's the end of our notes here. Okay? Then it's just coming down to practice it. How is the third example that we're going to go through different than the second example? One's a secant, so the 12 in the x line, let's make that purple here. This line is a secant, so we have a secant. And the other line is not a secant. It's actually a tangent, because it only touches the circle at one spot. So purple and blue? Sure, purple and blue. We have another line here that represents a tangent because it only touches the circle at one spot. So when you see a secant and a tangent that intersect where? Outside the circle. We have a similar formula that's a little bit different. We have a similar formula but just a little bit different. Okay? We're still going to do outside times whole equals outside times whole. However, when I look at the tangent, what's the number that represents the outside? 24. Everybody agree with that?
Yeah.
Tangents always are outside the circle. Okay? What's the length of the whole tangent? It's the same number. Right? It's always the same number. The outside and whole of a tangent are always going to be the same number. So rather than writing the same number times itself, what's another way I could write that? Squared. I could take the whole tangent and I can square it. Now, since I'm taking the whole segment and squaring it, right, the secant has inside and outside just like we already talked about, right? So the secant is going to follow the same rule as we did last time. Outside times whole for the secant piece. So secant is purple, outside times whole. That's the secant part. Tangent, I square it. Tangent, I squared that length. So let's go ahead and try this problem up here. The outside and the whole of the tangent are the same, so I'm going to do 24 squared. And that's going to be equal to outside times whole. On the purple line, what's the outside number? 12. And the inside number is obviously, it's going to be x. So is it 12 times x? It's got to be x plus 12. Don't make that common mistake of multiplying the 12 and the x. Okay? It's x plus 12 or 12 plus x. Does it matter which way I write that sum? No, because sums are commutative. It doesn't matter which way I write those two numbers. Now, if I'm solving this equation, I'm going to have to solve for x by first distributing. And also, what's this 24 squared? I'm going to need my calculator for that. What's 24 squared? 576. 576 is equal to 144 plus 12x. Hopefully we all know what 12 squared is. Yep, and I subtract 144 from 576. Oh, you said 4.
Oh.
Now, if 5, 7, and 6 are all greater than 1, 4, and 4, it's pretty easy subtraction. 4, 3, 2.
2.
And I'm now going to divide 432 by 12, and I get what for my x? 36. Box or circle your final answer, and you're good to go. That's really all 10.6 is. You just have to make sure you remember, when you look at the whole picture here, you have to make sure you remember which formula goes with which type of problem based off of what you see. Okay? And don't forget about your common mistake.